Okay, now we'll study about volumetric strain. So when a bar is subjected to stresses, it undergoes deformation in all directions. That is, there will be change in volume since there is deformation in all directions. So what is volumetric strain? The ratio of change in volume to original volume is called volumetric strain. So you consider a prismatic bar of length L. When it is subjected to some force P along its axis, there will be change in dimension in all the directions, that is in the x direction, y direction and in the z direction. So there will be change in dimension in all the directions. So there will be change in volume. So there will be a strain, volumetric strain. It is represented by the letter EV is equal to delta V, that is change in volume by original volume. So we can define volumetric strain as change in volume by original volume. So we can show this volumetric strain is the sum of strains in three mutually perpendicular directions. So we can show that the volumetric strain is the sum of strains in three mutually perpendicular directions. If EV is the volumetric strain, this can be written as EX plus EY plus EZ. For example, you consider a bar of length L, breadth B and depth D as shown in the figure. Now what is the volume of this bar? Volume, you can write V is equal to L into B into D. Now we can see that volume is a function of length, breadth and depth. So what is the change in volume? So if there is change in length, change in volume will be change in length into breadth into depth, plus if there is change in breadth, length into change in breadth into depth, plus change in depth, so length into breadth into change in depth. So if we are dividing this dV by original volume, that is dV by what is the original volume? L into B into D, and dividing all these by L into B into D, delta L into B into D by L into B into D, plus L into delta B into D divided by L into B into D, plus L into B into delta D divided by L into B into D. This becomes delta L by L plus delta B by B plus delta D divided by D. So you'll get EV is equal to, this is actually volumetric strain. This is the change in length in linear direction by original length, that is linear strain. Change in length in the lateral direction, delta B by original length, that is change in the y direction, B is in the y direction, plus delta D, that is change in depth, that's in the z direction, divided by original depth, that is EZ. Now we can show the same thing, that is volumetric strain is sum of strains in three mutually perpendicular directions in the case of a circular bar. You consider the circular rod of length L and diameter D. Now what is the volume of this bar? Volume of bar can be written as, volume of bar is, area is pi by 4 into d square. So volume is pi by 4 d square into length L. Now if we are applying some load, there will be change in dimensions in all the directions. So change in volume, there will be, since there is change in dimension in all the direction, there will be change in volume. So we can find out change in volume by differentiating both sides, that is delta V is equal to, pi by 4 is a constant. First we are taking the change in diameter, 2d into delta D into L plus pi by 4 d square into delta L. We have done this since volume is function of d and L, diameter and length. So let us find out what is the volumetric strain. Volumetric strain EV is equal to change in volume by original volume. So dividing this by original volume, pi by 4 into 2d into delta d into L divided by pi by 4 d square L plus pi by 4 into d square into delta L divided by pi by 4 d square into L. We will get this is equal to 2 into delta d by d. So this will cancel, pi by 4 will cancel, d square and d will cancel. So you'll get 2d into L and L will also cancel, 2d by d. Now here pi by 4 will cancel, pi by 4 will cancel, d square and d square will cancel. So this becomes plus delta L divided by L. Okay, so you have to express EV as EX plus EY plus EZ. So in this case, what is EY? EY is the change in, there will be change in the diameter. So change in dimension in both Y and Z direction will occur due to the change in diameter. Okay, in both Y direction and in Z direction there will be change in diameter. So EY you can write it is equal to EZ and that will be equal to delta D by D. So you have got 2 into delta D by D. That is EV is equal to, volumetric strain is the sum of strains in 3 mutually perpendicular directions. So as homework you have to do what is the volumetric strain of a sphere. You find out what is the volumetric strain of a sphere. Okay. Now you have studied about Poisson's ratio mu. You have studied about linear strain and volumetric strain. Now we can find out a relationship between volumetric strain and linear strain and Poisson's ratio. So the relation will be like this: delta V by V equal to linear strain into 1 minus 2 into mu. Okay. So we know that whenever we are applying some load, it is unlikely that any material will diminish in volume. That is, the reduction in volume will be very small. So we can take this delta V approximately equal to 0. So this equation becomes 0 is equal to E into 1 minus 2 mu. So you will get mu is equal to 1 divided by 2, that is 0.5. Okay, so we expect that this mu will always be less than 1 by 2. Mu will always be less than 1 by 2. Now for rubber, mu is equal to 1 by 2. That when you substitute in this equation, delta V by V equal to E into 1 minus 2 into 1 by 2, this becomes 0 right hand side. That is, delta V is equal to 0. That is, the change in volume in the case of rubber equal to 0. That is, rubber remains practically constant during the extension. Okay. Now for concrete, mu is equal to 0.1. So when you substitute in this equation delta V by V equal to E into 1 minus 2 into mu, E is equal to 1 minus delta V by V equal to E into 1 minus 2 mu. This becomes E into 0.8. So the change in volume delta V equal to E into 0.8 into V. So there is a slight increase in the volume when we are applying some force to concrete. Now for cork, the value of Poisson's ratio is 0. So when we substitute in this equation, we'll get delta V is equal to small a, or delta V is equal to V into small a. So there is an increase in change in volume, that is increase V into E, slight increase in volume. So in the case of cork, mu is 0, and when you apply a longitudinal pull, there will be increase in the volume in the other directions. Okay, that is why the mu for cork is 0, and it is used for closing airtight bars. Cork is used since we are applying a pull. It will increase in dimension in the other axes.